Okay, we're going to run through the answers for CFA 2 on Unit 1 here, Lessons 5 through 7. You guys have your hard copies here, so remember you'll be writing down answers in your work so you can use these as study guides for the test when you're reviewing your skills. Okay, number 1 talks about Ernesto's science scores. He scored a 95, a 68, a 92, and an 85. Okay, and our job is to find the median score and the mean score. We know the median is the one in the middle, and the mean is the average. Okay, so I've already listed them over here from least to greatest, so make sure you guys do the same with the test scores. Okay, so the median, I know it's the one in the middle, and I like to cross out as we go here. One high crosses out one low, and we work into the middle here. Okay, and we find out there's two of them, 85 and 92. So this one's a little tougher to find the middle of. You got to find out what's halfway between those two to find the actual middle. So you can line these up and add these up if you'd like to, and then divide by 2, and that'll cut that right in half for you. Some people know too, they can, when you go through here trying to find the middle, you can kind of play around with it and use your number sense. If I started out with 88, I can see 88 is 3 away from 85, but it's 4 away from 92, and it should be equidistant from that. So I can think, well then, if I go 88.5 or 88.5, now I'm 3.5 away from each. Okay, so some of you have the number sense to be able to do that. Again, others of you might want to add those up and get the total, then divide it by 2, and you'll get that same answer. So the median is 88 and 5/10 is the median score. And then the mean, with the mean here, with the average, we're going to go ahead and do it the traditional way and just add them all up. And in this case, we'll divide by 4 of them, of his test scores. So I've got my calculator here. I'll just add up where you can see it. We've got 95 plus 68 plus 92 plus 85. And I get a total of 340. Might be kind of tough to see those numbers up there, but when I add them up, I get 340, and I can divide that by the 4 tests that he took. So if I take 340 divided by 4, I get 85, and I think you can see that on the calculator here. So his mean is 85%. Okay, for his mean score. All right, so those are 2 of the main landmarks, data landmarks that we focused on finding this unit. The next question then talks about, is the median or the mean the better representation of Ernesto's overall performance? Or are they about the same? And explain your reasoning. We talk a lot of times about how some of these could be a little bit different, and some might be more accurate than the other depending on certain situations, like if there was a big outlier. So when I look at this one, I see that 68 is a test that's way lower than the rest, and I know an outlier like that will bring that mean down because the mean takes into account every score. So it's going to drag that average down to 85. And when I look at his test scores, he had a 92 and a 95 and an 85. So most of them are above an 85. So when I look at this, I think the median kind of portrays his skills a little bit better and shows what he knows. So I would choose the median is a little bit better representation of what this kid probably deserves and showing what he knows. And explain your reasoning, I would talk about the outlier bringing the average down in this case. So I would say the median better represents because the outlier brings the average down a little further, and maybe doesn't show what this kid knows as well, because that one really low score on most of the other tests, he did very, very well and was scoring above 85. So maybe would deserve that 88.5.
Jeff or Corey, if you're in the building, can you please call the office? Thanks.
Again, sorry for the interruption, guys. Sometimes they announce a little bit on there, so we'll go ahead and keep going here. Okay, number 2, Sophie sells hot dogs. We want to circle the graph. That she should show customers she wanted to convince them to buy hot dogs. 2 different graphs talk about pizza and hot dogs and hamburgers and what kids like the most. And if she wants them to buy hot dogs, she's trying to persuade them. Okay, she's probably going to show them this graph. Okay, so I'm going to circle that one because the hot dogs here, kind of hard to read, but you notice theirs look like they're a lot more popular because it's a lot higher on the bar. But we know in reality there's some things that can cause it to look like this. Okay, so why does the graph you chose support Sophie's hot dogs? Okay, because the hot dog bar graph is a lot higher than the other bars. Again, make sure you're writing these things in. And again, double checking our thinking here and making sure we understand these things here. It just looks a lot higher. Okay? So, why in this case do you think, why were these graphs changed? How were they changed and why? And so when I look at this second graph here, and notice the scale. We talk a lot about the scale. This one starts at 0 and goes by hundreds. Okay, and this one starts at 950 and goes by fives. So when you start scales at different spaces, different starting spots, it can really affect what the graph looks like. So how are they changed? The scales are different. Is the main one here, and we're not going to go talk about exactly how this one starts at 0. I'm not going to write all that. Or this one starts at 950, but that's how the scales are different. Okay, and some go by 100s over here, and this one goes by fives, and again, it makes all the data look different. So this one really supports the hot dog business because it's a lot higher. Okay, but in reality, if we really are understanding the situation, all of these things are close to equal in popularity. Okay, but she's trying to support her hot dog business, wants to look like it's more that it's more popular, so people will buy it. And then we had one more question on the back. If you want to flip over, we're going to read these histograms now, and making sure we understand these histograms. Remember, they're like a bar graph except they touch, and these are called bins. And that's how many people fall into those bins and how many people, the gifts they received, how many people received that many gifts in this case. Okay, so reading this, number 5, most students receive between blank and blank gifts. And I look at that highest bin, it looks like between 6 and 7. As I look right here, that bin has 9 people there. And that's question 6, how many students received between 6 and 7 gifts? It looks like 9. Again, reading that bar graph scale over here, we can see that they get 9 people fall into that bin. How many students are represented in the histogram? Remembering to do this now, you just need to add up every bin. So I would add up 2 plus 9 plus 6 plus 2 plus 4. And if I add those up, I believe you get a total of 23 students were accounted for in this data. So to wrap up here, in what ways is the histogram different from a traditional bar graph? Remember, the bars touch in a histogram, and actually we call them bins and not bars in that histogram. These are bins, and we think about how many fall into these bins. Okay, so it's a little bit different than a traditional bar graph. Okay. And those are the answers for the different CFA questions we studied last week.